Hey, welcome to Next Gen Manufacturing Nexus. Today we're diving deep into the smart factory. We're going to talk about something straight out of science fiction, teaching machines to literally see the future.
So let's just kick things off with a big question. What if the machines making all this stuff in our lives, our cars, our phones, could actually tell us, hey, I'm about to break, before it happens?
Because, right now, not having that crystal ball costs companies billions of dollars every single year. We're talking mountains of wasted parts, production lines grinding to a halt. The stakes here are just massive.
Okay, so to really get why the solution is so cool, we gotta first understand the problem. And it all boils down to something really simple, something physical: toolware.
Yeah, look at this. This chart really shows you it's not as simple as a tool just getting a little dull. Oh no, it's a full-on battle. You've got insane cutting forces, crazy high temperatures, the hardness of the metal. All these things are fighting against the tool at the same time.
And think about it. Every single time one of those tools gives out unexpectedly, boom, the whole production line can just stop dead. It's this one tiny point of failure that sends a shockwave through the entire system. And that means losing a ton of time and, you guessed it, a ton of money.
So, for years and years, we've been trying to solve this. But the way we check for this wear and tear has completely changed. We've gone from literally just using our eyes to listening in with digital signals.
And this is the real game changer, the move from direct to indirect monitoring. Okay, so direct is the old way. You stop the machine, pull the tool out, maybe look at it under a microscope. Sure, it's accurate, but man, is it slow. Indirect monitoring, that's the revolution. We just slap some sensors on the machine and listen to it while it's running. Production never has to stop.
This is so cool. Here's how we actually turn that physical action into pure digital gold. First, when the machine is cutting metal, it creates all these vibrations, right? Well, a single, pretty cheap sensor, an accelerometer, grabs that raw signal, but it's messy. So the next step is to clean it up, digitally filter out all the noise until you're left with just the data from the tool itself. And there you have it, clean, beautiful data, ready for some serious analysis. So what do we do with that data? Well, we break it down into what are called statistical features. Now, don't let the names like RMS or kurtosis scare you. Just think of them as the words in the machine's language. One word tells you about the energy, another about how spiky the vibrations are. Each one gives us another clue about what's really happening with that tool's health.
Okay, so we've got the sensors, we've got the clean data, we're learning the machine's language, and all of this is leading up to the really exciting part. This is where that data meets the incredible power of AI.
And we need to be super clear about this difference. Monitoring is just seeing what's happening right now. It's a snapshot. Prediction? That's the magic. That's using all that data to forecast what's going to happen next. It is the massive leap from reacting to a fire to preventing the fire from ever starting.
And to actually make these predictions, engineers have a whole toolbox of different AI models. You've got things like CNNs, LSTMs, a bunch of different approaches. Some are great at spotting patterns, others are better at seeing how things evolve over time. It's all about picking the right AI for the right job.
All right, so how good can we actually get at this? Well, check this out. Using a really advanced AI model trained on the data from just one cheap sensor, researchers were able to predict tool wear with, get this, 99.1% accuracy. That's just insane. 99.1% from a single sensor. Wow.
Okay, but hold on. There's a catch. It's the classic million-dollar question. Your AI might be an absolute genius on the one machine you trained it on, but what happens when you try to use it on a brand new, different machine? This is a huge challenge called generalization.
And these images, they show you the problem perfectly. On the left, you see the AI is killing it on its home turf, the machine it trained on. But look at the right. You move that same AI to a new machine it's never seen before and, oof, the accuracy just tanks. It's a textbook case of what's called overfitting. The AI basically got a little too good at knowing the first machine, and now it can't adapt.
So how do we solve that? How do we tie all of this together? Well, that brings us to one of the biggest, most powerful ideas in all of engineering today, the digital twin.
So what on earth is a digital twin? Think of it like a living, breathing virtual copy of a real machine. It's not just a pretty 3D model that sits there. No, this thing is alive. It's constantly being fed real-time data from the sensors on the actual machine out on the factory floor.
And this diagram, this is where the magic happens. Look, the real machine is constantly feeding data to its digital twin. The twin then takes that data and runs millions of what-if scenarios, predicting what's going to happen, figuring out the absolute best way to run. And then, and this is the key, it sends those optimized instructions back to the real machine. It's this incredible, continuous feedback loop where the machine is constantly getting smarter.
And the results? They're just staggering. We're talking about companies cutting their product development time by up to 75%. They're slashing the need for expensive physical prototypes by 80%. And of course, it makes that true predictive maintenance we've been aiming for a reality. It completely connects the design team with the factory floor in a way that was never possible before.
So when you put all these pieces together, what you're really looking at is a fundamental shift in manufacturing itself. We're entering a whole new era. This is the dawn of the predictive factory. You know, one of the research papers I read put it perfectly. They said that this real-time monitoring, it isn't just some nice little feature. It is the absolute heart of intelligent manufacturing. It's what makes autonomous production lines possible.
So if there's one thing to take away from all this, it's the sheer scale of this transformation. It's a complete change in mindset. We are leaving behind the old world of break-fix, where you wait for something to go wrong. Now we're in a predictive world, where we can step in and stop things from ever failing to begin with.
Think about that. We are literally teaching our machines to see the future. And yeah, it's solving this huge problem of toolware, but it's also opening the door to a whole universe of new questions we can ask. So that kind of leaves us with one last big thought, right? Now that they can predict the future, what do we ask them next?